we're going to first learn about defensive programming. And defensive programming is it consists of two things that you can do really to make your programs more, I guess, less likely to have bugs in them, to make your programming a little bit more solid, or it prevents us from mistakes that we would otherwise make. So the first one is assertions, and there is a built-in capability to do assertions in Java. And so we'll talk about that. It was added in, I don't remember which version of Java, one of the early versions. We didn't have it at first, and then they added it. And then the other one is parameter checking, which is just a technique that you can apply. So we'll talk about both of those, and then we will talk about when to do each of them. So first of all, as we program, we make a lot of assumptions about the state of the program or the code as we go. We don't always think a lot about those, but we do it all the time. So for example, as you're programming something, you'll often think to yourself, at this point, this variable can never be null, so I don't need to check for it. Or at this point, this value is always within a certain range, and so I'll write code depending on that. So if you think about that, you probably do that all the time. As you're writing code, you have these assumptions that you make, and you are sure that they have to be true, and based on your knowledge that they have to be true, that kind of determines what code you write. And so because we make those assumptions and then we rely on them, the correctness of those assumptions is really important. Our programs don't actually work if those assumptions end up being wrong. And unfortunately, they often do end up being wrong. And so this results in buggy and unreliable code. And so a better practice than just making assumptions is to actually put it in your code, what your assumptions are. And that's where we use assertions. So first of all, though, let's look at this example, this little program right here. It's a program that does a binary search on an array of ints. And so if you think about remember what a binary search is, you probably learned about that in either 235 or 236, I assume it's 235, where you would learn about binary search. And so a binary search is a search where you have your values, you pick a middle value and see if it's greater than or less than the value you're looking for. And if the middle value is greater than, then you know your value is somewhere from the beginning to that point. So now you chop the possible values in half, and you keep cutting it in half until you find the value. So that's a binary search. So if we think about that, think about this binary search program and ask yourself, what assumptions are we making about the parameters? If we're going to do a binary search and we're going to write the code starting here, what assumptions are we making? Does anybody want to answer that? What assumptions are we making about a binary search? Stockton, go ahead.
We need to assume that it's sorted.
Yeah, exactly. Binary search only works if your data is sorted. So we would be assuming, if we're just going to do a binary search here without sorting the data first, then we are assuming that the data is sorted. And there's probably one other assumption. Can anybody see one other assumption that we would be making here? Go ahead, Stockton.
Would we assume that the search value is within the range of the min and max of our data set?
Yes and no. We actually could do a binary search even if it's in the range. We would just not find it.
That's true.
So, Matt, you have a thought?
Yeah, that the array or whatever we're going through isn't empty.
Okay, yeah, that's the one I was looking for. And there are probably others we could identify, but that's the other one I was thinking of. The array is not null, and it's not empty. And if it is, and we try to search it without checking for null, we're going to get a null pointer exception. So those are the two assumptions that we make. And maybe you know that that's the case. If you are writing this function, you may know how it's being called, and you may know that the caller sorts the data first and then passes it in. And so you know it's sorted, and you know it checks for null and it doesn't call it if it's null. So in that case, you might make those as assumptions. You might say, I can assume that these things are true because I know they are. The problem is you can be wrong for one thing, but they could also become incorrect later. So maybe somebody changes the code and they're no longer correct. So instead of just relying on assumptions, we want to be able to put it in our code what our assumptions are so we can check them. So the way we can do that is we use assertions. So assert is a keyword in Java, and that allows us to state that that allows us to state that our assumptions are true, and they will be checked. And if they turn out not to be true, then we will get an error. So here's an example of one. We could say assert, and this assumes that there's a variable called temperature. So assert temperature greater than 32 and temperature less than 212. So we assert, and then the thing that we assert has to evaluate to a Boolean. If that is true, then our program continues, and if it's false, then Java will throw an assertion error at that point. And remember, assertion errors or any kind of error is something that you shouldn't catch, which means that that would crash your program, and the stack trace would tell you where the failed assertion is. And that's actually better. If your assumption is wrong, it's better to have your program crash right there than to give buggy or unpredictable results based on assumptions that should be true that aren't. Okay, so here's how we could do the two assertions that we just talked about. Assert data not equal null, assert is sorted. And what that would do is that assumes, it doesn't assume, we're calling a method here that is actually going to check to make sure that the data is sorted. And one thing you could notice about that, you could say, well, isn't that going to increase the time of this search? And I'm probably doing a binary search because I want it to be fast. And checking that it's sorted first is probably not fast. And so haven't I lost the benefit of binary search? You actually haven't, and I'll explain why in just a minute. So, but that's what asserts look like. They're just these statements, and if we get past them, we know that they turned out to be true. Here's another example, two examples. So if we look at this method, we have some method and we pass in two variables and we divide one variable by the other. That means there's an implicit assumption that z is not 0. And if it is, that's an error. That's undefined to divide by 0. So we should assert that z is not 0. And then if we look right here, we have some reason. Whenever I move my mouse down there, I get that pop-up, so I'll just keep it up above. We are assuming for some reason that once we do that division, x is going to be greater than 0 and less than 1024. I don't know why we would make that assumption, but we may have some requirements in our code where we know that should always be true. And so if we know that that should always be true, then we should assert it and do that with an assert statement. Okay, so these are like little test cases sprinkled throughout your code. They're not the same thing as unit testing. They are just little things that allow you to test your assertions, and that will, by doing that faithfully and religiously, you would avoid quite a few bugs that you'll probably otherwise get. Now, I mentioned before that one assertion where we checked that our incoming data was sorted. If we don't need to do that, that's going to make our search function a lot slower than it would be, and I told you that that actually isn't a problem. The reason it's not a problem is because assertions are normally disabled when we release the software. In fact, they're disabled by default. So by default, the assertions don't actually exist in the code. So when we run our program, the JVM strips them out. It strips them out in the bytecode, so they don't actually affect the running of our program. So in order to enable them, we have to use a flag. We have to enable them by using this flag, minus enable assertions, but that's really long, and so there's a shortcut. We can say minus EA. So if we're running our code from the command line, we would do something like this, Java minus EA my app. And what we have just done is enabled the assertions. So if any assertions fail, we'll see those. By default, they are not enabled. So what that allows us to do is run with them on when we're testing and writing our code. And once we have done that, once we have tested our code, we know it works, and we're confident in that, then when we deploy our code, the assertions are not there. So that lets us that gives us the freedom to write whatever assertions we want. We can actually just smother our code with assertions We can put them everywhere we're making assumptions, which is really what makes them useful, without being concerned that they are going to slow down the running of our program. Any questions about that? And because of that, because of the fact that they are off by default, they're different than unit tests. So with unit testing, it's not like tests that are always running, because they're not always running. They're usually turned off, or at least they're turned off in deployed applications. So they're there for kind of the development stage to help us make sure that we're building our code right when we're building it. We can also turn them on in IntelliJ, and I'll just escape out of here and show you quickly how we do that. So I can really show that with any program that has a main method in it, but I'll do the family map server one. So the way you do that is you go into the run configuration. The easiest way to get a run configuration is to run a program first. So just run anything that has a main method in it, and then it will show up right here in this drop down. And then all you have to do is click on that and go to Edit Configurations. And right here where it says VM Options, that's where I would say -EA for Enable Assertions. And now if I run it, any assertions that I have in there will run. By default, without that flag, they're turned off. Okay, sorry, I'm just trying to present this again. There we go. Things get covered up by Zoom. Okay, so the standard way to do that is just assert and then a Boolean. There is an alternate form of assert that sometimes is useful, and that is assert followed by a Boolean condition followed by a colon and then an expression. That expression gets converted to a string, and that becomes the message that's in your assertion error if it fails. And so in some cases we don't need that. In most cases we don't. If we look right here for the binary search ones, we don't really need to say binary search data is null in this one, because it's only ever programmers. Programmers are the only ones who ever see an assertion failure because we have them turned off in production. So if you're a programmer, you're looking at the code, you're running the code. So if you see an assertion error, you're going to see a stack trace, and if you click on it, it'll take you right to this line. So as soon as you see that line, you can tell if it failed, then this assumption is false, and therefore my data was null. So you don't actually need this string here, so we don't normally put a string, and we don't normally use this alternate form of the assert statement. The same thing is true here. If this assert fails, I know it's because the binary search data is not sorted, so I don't need a string to tell me that. But there are cases where that can be really useful. So if we look at this assert down here, it's really useful right here. So in this assert, if it fails, that's telling us that either x is less than or equal to 0 or greater than or equal to 1024. We don't know which one, and probably for debugging it would be useful to know what that x value actually is. And so that's a case where I would go ahead and I would use the alternate form and put the x there. I don't need a nicely formatted string that says the value of x should have been in this range, but it's not, this is what its value is. I don't need all that because, again, I'm a programmer when I see it, and if it fails, I go right to this line, and so all I really need to know is what the number is. I just need to know what the value is. So when we use this, we usually keep them simple and just give the information that a programmer needs in order to debug. So that's really when you would use this alternate form, is just if there is something useful to say that would save a programmer time or make it easier for the programmer to debug the problem. Okay, so are there any questions about assertions so far? Pretty straightforward, not one of the harder things that you have to learn. So let's think about this. Why don't we throw an exception if one of my assumptions is wrong? Just think about that for a minute. And really, the answer is right here, the second bullet point. You don't throw an exception if one of your assumptions is wrong, because if one of your assumptions is wrong, you need to fix the bug. You either need to change your assumption because your assumption was wrong, or you need to fix the bug in your code that caused the assertion to fail, that caused the assumption not to be true. So that's why we don't throw an exception. Exceptions are for cases where we had something that we can't fix in our code and it just can occur. Well, if we have a faulty assumption, we either need to fix our code or change our assumption, and exceptions don't help us with that. So that's why we don't throw an exception. We use the assert statement to let us know that one of our assumptions is wrong, so we have something to fix. Okay, so that takes us to another defensive programming technique. So the first one was assertions. The next one is parameter checking. So parameter checking is something that we do to just make sure that the values are what we expected when we call a method or a function. And that's really what some of my asserts were. And so we need to indicate if the incoming parameters are not what we expected or if they're not okay. Because if they're not okay, if they're not what we expected, we're going to probably get a bug somewhere. We're probably going to have a failure somewhere, but it could be later, and it's going to be harder to dig through our code and find where it is. So it's better to just know right up front that there's a problem with the parameter. So we want to check that as close to where it occurred as possible, which is when it was passed in. So there are two ways to do this, two ways to do parameter checking. We can either do it with asserts. Not all asserts check parameters, but a lot of them do. So these two asserts, we're checking the parameter. So that's one way we could do it. The other way is we could throw an exception if our assumption is not satisfied or if they're not okay. So then we have the question, which one should we use? For parameter checking, should we use assertions or should we use exception throwing? And there's a pretty simple answer to that. If you have control over the code that's calling the method that's throwing the exception. So in other words, if you have control over the code that is passing the bad parameter in, then you should use an assertion. And when that assertion fails, you should fix your code. So that's the preferred thing. If you don't have control, so for example, maybe your method is a library that you make available to other people. And so you don't control the code that calls it. That happens external to you. Then in that case, you don't have a way to fix their bug. So if they have a bug that causes your assertion to fail because they pass you a bad parameter, you're not controlling that code, you can't fix it. So throwing an assertion does you no good. And what you need to do instead is you need to notify them even at runtime that they did something wrong. So in that case, that's when you would throw an exception. So to summarize that, use assertions for parameter checking if you're in control of the calling code. Use exceptions if you're not. So are there any questions about that? The concept of when or why I would use assertions if I control the calling code and exceptions if I don't. Okay, well that wasn't a very hard topic, and that's what I have to say about parameter checking.